Hey guys, welcome to episode 62 of Reconstructing Cave Story. In the next few episodes, we're going to be implementing our slope tiles. The first thing I want to do is provide a collision tile that can test for collision and determine the position of a collision given a side. So this is going to be strictly a refactoring. We're going to be taking our collision tile, which right now is in our map.h class. And as you can see, it's just a C-style struct with the row, call, and tile type are all public. And I just really want to abstract that out so we don't need to know the details and do calculations with the row and call and the tile type. So that's what we're going to be doing in this episode. Our implementation is going to make use of the new boost type. It's not new to boost, but it's new to us, and it's a boost optional, and it takes in a template parameter for a type T. And T is either there or not there. So it could be there, and otherwise it would be boost none, which is analogous to null. So, okay, so the semantics are really similar to boost smart pointers. I should say that, so you can get at the value by saying star variable, or you can do something with the variable by doing variable arrow. So it's really similar to boost smart pointers in terms of semantics. It's not actually a pointer, it's just template magic, but yeah, you can kind of think of it as a pointer that could be null. So that's what boost optional is. And the naming convention I use is I put a maybe underscore in front of it. I like that instead of optional before it, and yeah, it works for me. So struct collision tile, that's what we're going to be building. It's going to have a test collision method instead of having all the public row tile or row, call, and tile type. And it's going to take in a single side type and a position, and the side type is going to represent the side that is getting collided with, the side of our tile that is getting collided with, and the position is going to represent the position against the grain. So I'll put a comment in when I create the method header to remind us of what it's for. And then it's going to return a boost optional, units of game, and it's going to represent, this units of game is going to represent the point of collision if there was one, and then otherwise, if we get boost none, there was no collision. So that's how we're going to signal it, and it'll work out pretty nicely instead of returning a struct or anything like that. So yeah, let's get started. So the first thing I want to do is I want to find side type, and I want to move this side type off to its own file so that we don't have header collisions and circular includes and stuff like that. So I'm going to move this side type into its own file and then put it in a namespace too. So I'll edit cave story source side type.h, create some guards and a namespace. I'll call the namespace sides in keeping with our units naming convention. And I'll move the side type in there. So we're going to need to include it in map collidable. Okay, so now there's another change we need to make is side type is inside of map collidable right now, and we just moved it into namespace sides. So we're going to need to do a big find and replace. So I'm going to do sed-r for extended regex because I'm going to use some extended regex magic, I for in place, and then we'll see if there's a map collidable. There might be, there might not be. If it's inside of map collidable, there won't be. So we'll change map collidable. We'll see if it's there. Maybe it is, maybe it isn't. So that's what the question mark does. And then we're going to find side type or any of the variables. So it's left or right or top or bottom side. And we're going to replace that with sides, : and then the second capture group, which is either the side type or one of the enum values. And we could do that for every single file and source except for that new file we just created, which was side type. And that's what this does in Z shell. It's just, this says ignore anything that matches this pattern. So we can go back in and load that up, and we see that sides was indeed replaced, or inserted in this case. and side is still fine here. So I'm going to do this for a couple more things. First is tile type. I want to move tile type to its own class. So edit cave story source tile type.h header guards and a namespace. We'll call this namespace tiles. We're going to put more functionality in here, so it's not just the enums. But I especially just don't like having naked constants like this, because then you get naming clashes and stuff like that. So now we have tile type, and we need to update map. So we'll include tile type. And then we need to do our sed find and replace, because now it's inside of namespace tiles and out of the namespace maps. So sed-ri. So I'm going to try something. Yeah, okay, this will work. So we will replace, there might be a map : in front of it. Maybe not, question mark. And it is going to be tile type, or it's going to be air or wall tile. And we can just replace this with the second capture group, or tiles followed by the second capture group, which is this tile type or air or wall tile. And then we want to do this for every single file except for the new one we just created, which was tile type, because we don't want to scope it inside of the namespace itself. Unterminated S command means that I forgot to put a :g or a /g at the end. There we go. So source map has changed. Yes, we've got tiles in front of it, and tile type is unchanged, which is great. Next, I want to take out CollisionTile and move it to its own file. We're not putting it in a namespace, but we still need to do a special sed stuff. So I'll do case story source CollisionTile.h guards and grab CollisionTile and put it inside of our CollisionTile.h. We'll need to include a couple things: tile type.h and units.h. And inside of map, we'll now need to include CollisionTile. So let's go back up here and include it. So now we're going to need to do our sed thing, because again, CollisionTile was in the scope of map. So let's do sed-ri, and I will find maybe map, maybe not, and then CollisionTile, and just replace it with CollisionTile by itself everywhere. Everywhere this time, we don't need to exclude anything. And now I can make clean and make, just to make sure everything is compiling. It should be. I'm expecting it to compile at this point. And it compiles, great. Before we change up a CollisionTile, I'd like to make add a couple of helper methods to our side type so that we can get the opposite side. So I'm going to create an inline, just return a side type, opposite side, taking in a side type side. And this way it'll be easier to get the opposite side when we're like trying to get the side in direction of delta and then the other side. So this will kind of clean things up there. So I'm going to say if side is top side, return bottom side, just straightforward generic implementation. And then finally, we'll just return left side in all other cases, because the only other case should be side is equal to right side. Another one I want to make is I just want to determine if it's on the horizontal axis or the vertical axis. So I'm going to create an inline bool vertical taking in a side type. And this is just going to return side is top side, or side is bottom side. And then I can create horizontal easier than this with inline bool horizontal side type side is equal to, or return vertical side, or not vertical, I'm sorry. So now we have a few helper methods. There's one more I want to create, and this is specifically for the Polar Star CC. We have horizontal facing and vertical facing, and I need to be able to translate those into a side type pretty easily. So I'm going to include sprite space where that is now. And then I'm going to create an inline side type from facing. And it's going to take in a horizontal facing and a vertical facing, and just translate this into a side type. So this only goes one way, so there's more information being held in H facing and V facing than there is in the side type by itself. So this is only a one-way reduction of information kind of translation. So we're going to say if V facing is equal to top, we want to return, or it's not, sorry, not top, but up, we want to return top side. If V facing is down, return bottom side. If H facing, because now we're sure that V facing is horizontal, is left, return left side. And then finally, we'll just return right side.